In this video, we're going to go over example 3 and example 4 on one-step equations involving multiplication. I'm going to start by just drawing a line down the center of the equation to separate the left side of the equal sign from the right side of the equal sign. I'll go back to scribble, if it will let me. And then it says what side is the variable on, and the variable is on the right side. The x is the variable, and it's over here on the right. What is the problem number? The problem number is negative 11. That is the number that is keeping the x from being alone on the right side. What is the original operation? Well, you can't see anything in between the x and the 11. In between those two, you don't see anything, so that means that it's multiplication. I'm going to draw in just like a dot here in the middle to show, remember that symbol means multiplication. So the original operation is multiplication, which means that the inverse or opposite would be division. Now I like to use a fraction bar for division, so I'm going to show division like this. So we're doing the inverse operation to undo the multiplication and to solve this problem. We divide each side by negative 11. The reason why it's negative 11 and not negative 143 that we divide by is because you're always going to divide or multiply or add or subtract by the problem number, by the number that's keeping x from being alone, because the point is to make that problem number disappear so that x is alone. Now, negative 11 divided by negative 11 is equal to 1. Recall that anything divided by itself is going to equal 1. So I'll take another color here, and I'm going to draw a 1 through this negative 11 divided by negative 11, and we are left with 1x. This means that we've just isolated x, because remember, the problem is solved. The x, or the variable we could say, is isolated when the coefficient is 1, and there's nothing else on that side with it. Now I need to take negative 143 and divide it by negative 11. So I have a way to help us remember how to change this to long division. There's a picture down here below, and I want you to think about the top being the writer. Okay, so the top is the writer, and then the bottom is the horse. So I'm referring to this image over here. The numerator is, I'm going to call the writer, and the denominator is the horse. When you think about going into a house, the horse is going to stay outside, but the writer could go inside the house. Okay, so the denominator goes on the outside, the numerator goes on the inside. So now I'm going to go ahead and do the same thing with my numbers. The horse, the 11, goes on the outside, and the writer, the 143, goes on the inside. Now I recorded these both as positive numbers because I know that a negative number divided by a negative number results in a positive number. You are going to learn that in 7th grade. You don't need to know that yet, but it's not bad for you to hear right now. We'll do that. We'll talk about that later in our unit where we talk about integers and rational numbers. All right, how many times does 11 go into 14? It goes in 1 time. I put it over the last number in the 14, so the 1 should go over the 4. 11 times 1 is 11. Then I subtract. 4 minus 1 is 3. And then 1 minus 1 is 0. Next, I have to bring something down before I ask myself the question again. Once I've brought a number down, I can ask, how many times does the 11 go into 33? It goes in 3 times because 3 times 11 is 33. When I subtract this, I have a remainder of 0 and there's no more numbers to bring down, so I've finished dividing this. So negative 143 divided by negative 11 equals positive 13. 1x is the same thing as x. So we get x is equal to 13. All right, we're moving on to example 4. I already filled in that the variable is on the right side, k is on the right side. I also rewrote it because I want to be able to fill in between a symbol. You'll see in a second. What is the problem number? The problem number is the 14. The 14 is keeping k from being alone. What is the original operation? Well, the original operation is multiplication. Remember, When you don't see anything in between the number and the variable, it means multiplication. So I put in my multiplication sign. What is the inverse or opposite operation? That would be division. So we're going to divide both sides by the problem number. We're going to divide both sides by the 14. Now on the right side, I'll use a different color to show that 14 divided by 14 is equal to 1. So we're left with 1k is equal to, and then I need to divide 126 by 14. Remember, the numerator is like the horse and it stays on the outside. And I hope I said denominator. The denominator 14 is like the horse and it stays on the outside. The numerator is like the writer in the picture and the writer goes on the inside. So 126. And I just left those both positive because I know that a negative divided by a positive, I'm going to just go ahead and put the result is going to be a negative. Again, you don't have to know that yet. You're going to learn that later in the year. All right, 14 goes into 12 0 times. So 14 goes into 126. I don't know, let's guess. 10 would be too much. I'm going to estimate about 8. 4 times 8 is 32. Okay, that's not going to work out perfectly. I bet it will work out perfectly. So I'm going to try, well, I guess I should finish this. That wouldn't be enough. So let me try 9. 4 times 9 is 36. Carry the 3. 1 times 9 is 9. Plus 3 gives me the 12. So it'd be exactly 9 times. And then I subtract and I get a remainder of 0 and there's no number to bring down. So we get our answer to be k equals -9. Remember, 1k is the same thing as k.